In the previous video, we discussed the 5 main components of SQL: DDL, DQL, DML, DCL, and TCL. We also talked about prioritization. For modern data interviews, about 95% of questions focus on DQL, while DDL and DML together make only up to 5 to 10%. DCL and TCL are almost never asked. In order to jump right into DQL and learn, we first need to understand some basics of databases, table creation, data insertion, modification, and maintenance. Due to this reason, learning some basic DDL and DML commands and their usage would be perfect to start with. In the first set of videos, we will talk about table creation and data insertion commands like create, insert, update, and alter. We will also go through the practical application through a coding environment. In the next set of videos, we will talk about data and table deletion commands like delete, drop, and truncate, also followed by a practical application. Without further ado, let's get started. Let's begin with the create command. Create is the starting point of DDL. It's used whenever we want to build new data resources. Let's use the create command to create a database called Amazon e-commerce. The syntax for this command is very simple. It's create, database, database name. In this situation, we will put create, database, Amazon e-commerce. After creating a database, the next step is to create schemas. Now let's use the create command to create a schema called products. Syntax for creating a schema is create, schema, schema name. In our example, it is going to be create, schema, products.
The next step in this process is going to be creating tables. But before we go there, we need to learn some data types of SQL, especially PostgreSQL. For this course, we'll be using PostgreSQL, one of the most widely used relational databases, and the syntax of Postgres is widely accepted in the interviews. For the rest of this course, we will be using PostgreSQL. Let's quickly review the most common data types in PostgreSQL. Int for whole numbers like 1, 2, 3, 1000, etc. Float for decimal values like 1.5, 2.44, 3.594, etc. Text and VARCHAR for strings like speaker, fan, laptop, etc. Text type is used for dynamic character length, which is enough for most cases, or VARCHAR if you need variable character length. N is denoted for character length in VARCHAR, like VARCHAR of 3 for country codes like USA, IND, etc. VARCHAR of 5 for US zip codes 98005,
64109, etc.
Date for calendar values like January 15th, 2026, etc. Timestamp for both date and time together like January 15th, 2026, 10:30 a.m., etc.
Timestamp Z for date, time, and time zone together.
Like January 15th, 2026, 10:30 a.m. UTC denoted by -07. Boolean for true or false values such as yes or no flags. These are the building blocks we'll use when defining columns inside tables. Don't worry about remembering exact specific data types in your mind always. Remember, this is just to enhance understanding while creating tables. Now that we know our data types, let's move on to the create table command. Create table is used to build new tables inside a schema. A table is where we actually store our data. For example, let's create a table called product info in our product schema that we created earlier. This table could have columns like ID, an integer for product identifiers like 1, 2, 3, etc. Name, a text column for product names like laptop, mobile, or fan, etc. Price, a float for decimal values of product price like 499.99 or 1200.50, etc. created at. A timestamp for when the product was added like January 15th of 2026, 10:30 a.m., etc. Each column is tied to one of the data types we learned earlier.
The syntax for table creation is create table product.productinfo open brackets ID space int comma name space text comma price space float comma created at space timestamp, and the bracket is closed and end with a semicolon. This is how we create a table with columns and data types in PostgreSQL.
So now we have created a table. The next step is to insert data into a table. Insert command is used to add new rows of data into a table. First, let's insert one row. In this example, we want to add a product with an ID of 1, a name of laptop, a price of $999.99, and a created at date of January 15th, 2026. The syntax for this is insert into product.productinfo, open regular brackets, ID, name, price, created at, close brackets, then use the command values, open regular brackets, 1 comma laptop comma 999.99 comma 2026-01-15 close brackets. This will insert a single product row into our table. Next, let's insert many rows at once. In this case, we want to add 3 products: ID1 laptop at 999.99 on January 15, 2026. So ID2 phone at 499.50 on January 16, 2026. And ID3 headphones at 199.99 on January 16, 2026. The syntax for this is insert into product.productinfo, open regular brackets, ID, name, price, created at, close brackets, then use the values command again, open regular brackets, 1 comma laptop comma 999.99 comma 2026-01-15 close brackets, comma, open brackets, 2 comma phone comma 499.50 comma 2026-01-16 close brackets, comma, open brackets, 3 comma headphones comma 199.99 comma 2026-01-16 close brackets. This way, multiple products are inserted into the table in a single command. So now that we know how to insert data into a table, the next step is to learn how to update data. Update command is used to change existing values inside a table. First, let's see how we can use the update command to update a whole column to a single value. For example, if we run the command update product.productinfo set price equals 100. This will change the price column to 100 for every single row in the table. But what if we only want to update one row, not the whole column? That's where the where clause comes in. The where clause is like a filter. It tells Postgres which row or rows to update based on a condition we give it. For example, let's say we want to update the price of the product with ID1
from 100.00 to 899.99.
The syntax for this is update product.productinfo set price equals 899.99, where ID equals 1. Now only the row with ID equals 1 will be updated. Finally, we can also update multiple columns in that one row. For example, let's say we want to update the product with ID 2, change the name to smartphone, and change the price to 550.00. The syntax for this is update product.productinfo set name equals smartphone, comma, price equals 550, where ID equals 2. This way, we can update more than one column of a row in a single command. Now that we know how to insert and update data, the next step is to learn how to alter a table. Alter command is used to change the structure of a table. First, we can use it to add a new column. For example, let's say we want to add a description column to our product info table. The syntax for this is alter table product.productinfo add column description text. Next, we can use alter to change the data type of a column that's already in the table. For example, let's say we want to change the price column from float to integer. The syntax for this is alter table product.productinfo alter column price type integer. But keep in mind, when we change a float to an integer, the decimal values are cut off. For example, 899.99 will become 899 and 550.50 will become 550. So we lose precision when decimals are converted to integers. That's something to be very careful about. We can also use alter to rename a column. For example, let's say we want to rename the column name to product name. The syntax for this is alter table product.productinfo rename column name to product_name. Finally, we can even use alter to rename the table itself. For example, let's say we want to rename the table product info to product details. The syntax for this is alter table product.productinfo, rename to product details. So the alter command is very powerful. It lets us change and reshape the structure of tables without needing to recreate them. So far in this video, we have learned how to create databases, schemas, and tables. We inserted rows of data, updated them, and even altered the structure of a table. These are the essential fundamentals you need to understand before moving forward. In the next video, we will do a quick practical execution so you can see these commands in action. And right after that, we will continue with the remaining commands: delete, drop, and truncate.
Preparing for data interviews isn't easy. LeetCode has SQL and Python problems, but they're not really built for data professionals. You juggle SQL here, Python there, and data modeling somewhere else, and still don't feel ready. That's why we're building Pipecode, a platform designed just for data professionals. Data modeling you can finally practice, SQL and Python questions from big tech data interviews, AI-powered mock interviews that feel like the real deal. Pipecode, launching Q1 2026. Learn, practice, succeed.